In the last lecture, we have looked at some important programming concepts such as variables and expressions. In this lecture, we will expand on these topics, and we will also look at how to trace our programs. So in the previous lecture, we have looked at the concept of variables, which allow a program to store values and move these values around the program. We also looked at how to use basic arithmetic operators to write simple mathematical expressions. In this lecture, we will expand on those topics covered in the previous lecture. First, we will look at the concept of constants, which is the opposite of variables, in the sense that constants are values which are stored in memory and should not change throughout the execution of programs. We will also expand on our vocabulary of variable operators in Python. Also, we will see how Python provides additional functionality that allows us to represent complex mathematical expressions in our code. Last, we will look at the concept of program tracing, which comes in handy when you want to study the behavior of your code. We have seen in the previous lecture that a variable is basically a name to a memory location that holds some value. Consider, for example, the statement x equal 3. So what does Python do? It creates an identifier or a variable which is called x, and this identifier will point to some memory location, and that memory location will contain the value 3. So this would be your variable, so variable name or your identifier, and this basically will be a memory location which contains the value 3. Now, as the name variable indicates, a variable is basically a quantity that tends to change. So this is something that will change throughout the execution of your program. Consider, for example, the following code, which computes the square root using Newton's method. Assume that the input here is 4 or 4.0 because we have a float. So c initially will be initialized to 4.0. So the value of c is 4.0, and also the value of t initially will be 4.0. However, in this loop, the value of t will change frequently. So this is a loop, and we'll study loops later on, but what will happen in here, we will have a repetition. So this statement will be will modify the value of t quite a number of times. So you're going to be computing some kind of quantity here, and that quantity will update the value of t. So t, initially, it will start with a value of 4, and then it will become 2.5, and then 2.05, and then 2.006, and so on until it becomes 2.0, and at that time the loop will exit. So as we can see, this quantity here of the variable t changes over time throughout the execution of our program. And this is expected of most variables. So most of your variables that you will create in your program, they will tend to change. However, not all the values in our programs should change, and we need a mechanism to define such values or such quantities that are not supposed to change throughout our programs. And that's the definition of a constant. So a constant is basically a value that doesn't change throughout the execution of a program. And we have many examples of constants. Consider, for example, the golden ratio. And the golden ratio is basically a special number which is equal to or approximately equal to 1.618. And it appears in many times, such as geometry, art, architectures, as well as other areas. Another famous example is the number e, also known as Euler's number. And it's a mathematical constant which is equal to 2.71828, and it appears as the base, or it's used as the base of a natural logarithm. Also, a famous constant is the number pi, which is a mathematical constant that is defined as the ratio of a circle's circumference to its diameter. and this constant is approximately equal to 3.14159. And one question in here is, how do we create constants in Python? So it turns out that you cannot actually create constants in Python, at least not in the same way you can create constants in other programming languages such as Java or C++. Instead, Python programmers use a style convention defined by the PEP8 style convention guide, where they create variables and write them in capital letters with underscores separating between the words, to hint to themselves and to other programmers as well that the values stored in such variables are supposed to be treated as constants. So here is the code we have seen in a previous slide. In this code, the value stored in the variable named epsilon is supposed to be treated as a constant. And the way we know this is because we have written the variable name epsilon in capital case letters according to the style convention guide, or the PEP8 style convention guide. And once we assign some value to the variable epsilon, we never change it throughout the program. So throughout our program here, we never actually change the value of epsilon. Here are a few more examples of good constant names that you can use in your programs. So for example, max overflow is a constant name, or can be used as a constant name because it's all capitalized and you have an underscore which is separating between words. You have total, speed of light, and dark red. Because a Python constant is just a normal variable, the Python interpreter will not actually stop you from changing the value of a constant. Consider, for example, the following code. So in this code, the aim is to calculate the area of a circle. So consider that we are having a circle. So let's say that we have a circle, and the circle has a radius r. So that's the center of a circle, and this is the radius of a circle. So the length of that line is the radius of the circle. The area is defined by the formula. So area is equal to pi multiply radius squared. And that's what this formula down here do. So this formula over here calculates the area of a circle. So remember that this is the exponentiation operator. Now in order to do this computation, we have defined up top here the value pi. And as we have seen, pi is a mathematical constant. Hence we have defined the variable name in capital case letters. The second line over here obtains the input. So this obtains the input from the user and then converts it to a float. Now let's say by accident you as a programmer inserted this statement which basically adds 1 to the value of pi. So remember, pi is equal to 3.14, and it adds 1 to 3.14, so the updated result of pi will be 4.14. So by the time you come down to this line, or by the time the interpreter comes down to executing this line, the value of pi will be 4.14, which will give you an incorrect result in the area. So the value of area here will be incorrect. So this will be incorrect because we have changed a value of what's supposed to be a constant, and this should be avoided. Now the Python interpreter will not stop you from doing this. So basically this statement here is considered to be okay in Python. But you as a programmer, as soon as you see that some variable name is capitalized, you should make an assumption that it is actually a constant, and you should avoid assigning it or updating the value of that constant. Because if you do so, this will likely lead to a logic error in your code. To see how constants are used in practice, let's go through an example problem. And the problem that we look at comes from the field of physics, and it is about calculating vertical displacement. So the goal of this problem is to write a Python program that computes the vertical displacement of an object, or also known as a projectile, when it is thrown up the air after some time t. Now the vertical displacement of an object that is thrown in the air or thrown vertically is given by the formula y equal y0 plus v0t minus half gt squared. And in this case, y0 is basically, so this is basically the initial or the starting point. So this is starting point of the object, and it is the vertical starting point because we are dealing only with vertical movement only. v0 is the initial velocity, so this is the starting velocity of the object at which the object is thrown, and this is usually given by meters per second squared. And t is the time after which we want to calculate the position of the object. So basically after t seconds we want to find out where has our object has reached. And the value g here is basically a physical constant. So this is basically a constant which is equivalent to 9.80665. And the goal is to basically calculate the position y after we have thrown this object in the air. Now, as we have done with the field perimeter problem, take some time and think about what is the input to this problem, what is the output, and how do we do the calculation. So what calculations that needs to be done. So take some time after this video stops and think about these three, and we'll see the solution in the next video.